Hey, hi, welcome to my channel, and today we are going to talk about JPA, and this is going to be a complete hands-on session where we are going to make our jobs app persistent, which means we are going to save or we are going to add the ability wherein our application will be able to save all the information into a database. And we are going to make use of JPA for this. So this is going to be an amazing hands-on session where we will continue building our job app. And this video is a part of Microservices series where we will first build a Spring Boot application and then we will convert that Spring Boot application into a microservice. Okay, so there is going to be a lot of learning. If you haven't subscribed to my channel yet, you should subscribe and hit that like button. Also make sure to enable notifications. Every subscription that I receive on my YouTube channel just motivates me to bring in more such amazing content for you all. Okay, and this content is freely available, so just make sure to avail the benefit of it. Also, to get access to the rest of the video, you can check out the description where you will have the link for the entire playlist. So without a further ado, let's get started.
Hello everybody, welcome to this class. So let us start talking about JPA and understand what it is. So we now have a job class and now we need to store that job class into the database. So what I mean by storing the job class into the database is whatever information that we are having in the application with the help of this job class needs to persist and gets saved in the database. Now, how would you do this? So one way is you create everything manually, like you have ID, title, description, like all the other fields that you have in this particular class, you can create it into the database. But there is a better approach with the help of JPA. So JPA stands for Java Persistence API, and it allows you to convert objects into relational table. Okay, so here you can see this class job has these fields and it will be converted into a table of this type. So all the fields will get converted into columns this way. So this is where JPA comes in, wherein this translation of objects into the relational tables is being done by JPA. So you can think of it like a specification that you specify, okay, and a blueprint you can say. So this blueprint is then converted into relational tables. Now before JPA, you had to manually create these tables with the help of SQL queries. But now you can just mention the specification and table creation is automatically taken care of with the help of the specification that you have just mentioned. Now what is the advantages of using JPA? So number one thing is, of course, it's easier and it's simpler to follow. So it's much easier to write and understand than doing a handwritten mapping. So like I mentioned, the another approach was to do everything manually, but that was more cumbersome. JPA makes writing query easier. Okay, so if you want to query your data, it's much more easier with the help of JPA, and it helps us write queries in the form of entities rather than SQL. So you can make use of objects within Java to query the database. JPA also allows us to save and update the objects, and this is without using any DML language at all. Now what I mean by DML language? So DML stands for data manipulation language, like update and insert queries. So if you want to update anything or insert a new data into the table, you can do that with the help of JPA itself, and it takes care of everything around that. Another advantage would be it has easy integration with the Spring Boot framework. So there is a small dependency that you need to add and you are done. So Spring Boot has an inbuilt support for JPA and it can be just activated with the help of a dependency. So this way JPA is really useful when it comes to converting your classes or objects into underlying table. So that's about JPA. Thank you. welcome to this class. Let us start talking about the data layer. So we have three layers like we discussed. We have presentation layer, service layer, and the data access layer. So we are going to talk about this layer which we have not defined yet for our application. So we need to create this layer, and this layer would be responsible for performing the CRUD operation. So what do I mean by CRUD operation? CRUD stands for create, read, update, and delete. Like for example, you have jobs. So you are creating a job application. So you might want to create a job, read a job from the database, update a job, and delete a job. So that is commonly known as CRUD. So CRUD is a common set of operation that is performed on any database. So to do this operation, we will need a set of these methods. So you will need find all, which will be responsible for getting all the jobs from the database. You will need get job, which will give us a particular job depending on the ID that we give as a parameter to this method. So this is for getting all the job. This is for getting a particular job. Then we have the update job as well, which will update the job, whichever job you pass in. And then you have delete a job. So this is just an example that I am giving you. We also have create job, which I have not added here. But create job will also create a job for you. So instead of creating these methods into our application, okay, and these methods will act on the job class. So we don't have to define this. We need to create an interface and use something called as JPA repository, which is the part of JPA. And that repository has the standard implementations that are needed for a typical database driven application. So you need to define only special cases which are not standard and they are particular to your use case. But the standard ones on any class or on any object like updating, fetching, deleting, creating are all predefined. Now the question is, how can you create an interface using JPA repository? So this is a syntax. You can specify JPA repository, entity name, and the primary key type. And this is something that we are going to see shortly. So that's about the data layer. Let us start talking about the H2 database. So what is H2 database? So H2 database is a open source relational database, and it has been written in Java, and it's incredibly fast for building Java based applications. So that is something that we are going to use. So what you can do is you can head over to Google and search for H2 database, and you will be shown this official website over here, H2 database engine. So you can go to this website, and I have this open over here. So what is H2? So these are some of the features of H2. So it's an SQL database which is based on Java. Now what I mean by it's based on Java, it's written in Java and it can run anywhere wherever Java runs. And this makes it perfect for development testing or even deployment in certain scenarios. Now it is pretty lightweight and it is not supposed to be used for production based environments. So as long as you're building applications for testing, and if you need something that is really fast and get you started quickly, that is where H2 comes into picture. So as you can see, it's fast, open source. Now it has embedded and server mode. So what do you mean by embedded and server mode? So embedded mode means the database runs within the same JVM as your application. So that's what is embedded mode. While server mode means that it is running on its own, which means it has a separate process of its own and it's running as a server and it can accept connections from the clients over the network. So this embedded mode is beautiful and it makes sure that we can embed it into our application. Also, H2 database has a browser-based console application using which you can see what tables have been created and what data is being stored from our application into this particular database. Also, it is pretty lightweight. As you can see over here, it has a jar file of around 2.5 MB in size, which is really small. And it is also known for its quick start. Okay, so it's really fast, and it also makes your application faster. So you can see over here, it's fast, open source. So these are more features that have been mentioned over here. So this is something that we are going to use, but right now you don't need to download or install this database. So you can use this website to learn more about what this is and how does this database work. But instead, we will be activating this particular database within Spring Boot with the help of a small dependency that we will add. So that's about H2. Let us start talking about how can you configure your project to work with JPA and databases. So setting up JPA with Spring Boot is a fairly straightforward process, and thanks to auto configuration capabilities of Spring Boot. So to begin with, we need to first add the Spring Boot data JPA. Okay, so what I'm going to do is I'm going to head over to start.spring.io, our favorite website. Okay, I'm going to make sure that I have Maven selected here. Okay, and I'll go ahead and say add dependencies. Now over here, I'll search for JPA. So this is a dependency which persists data in SQL stores with JPA. So Java Persistence API using Spring Data and Hibernate. So within this dependency, it makes use of Spring Data and Hibernate. Okay, so I'll just select this. Now this JPA dependency also provides support for ORM in Spring Boot applications. Now what I mean by ORM is object relational mapping. Now this is the process of converting your objects in Java to the relational tables. Okay, that is what is known as ORM in simple terms. So whatever fields you have within the object are being converted or mapped into columns. Okay, and this particular dependency also allows you to define entities, repositories, and also utilize the JPA features that are needed for data persistence and retrieval. Okay, so it enables you to work with relational database and leverage the JPA functionalities for data access. Okay, so this is one dependency that we are going to need. Now another dependency will be H2. So since this is the database that we are going to use, so you can see it's a fast in-memory database that supports JDBC API with a small footprint, and it supports embedded and server modes, okay, as well as browser-based console application. So I'll just select this. So Data JPA provides a way for us to work with data. It makes our life easy. And H2 database is the database that we need in our application. So now what I'm going to do is I'm not going to download this project or create a new project over here, but instead I need these two dependencies, and we have already a project set up in Intellij. So I'm going to go to Explore. I'm going to make sure that I have pom.xml selected. Okay, and I'm going to scroll down here, and under dependencies tag, you will see two dependency over here. Okay, so these are the two dependency. So one is the Spring Boot starter JPA, and then you have H2 databases. So I'm going to copy these two dependencies. Okay, I don't need anything else. Okay, and I'm going to just close this. So make sure you have Maven selected over here. If you don't have Maven selected, and if you click Explore, you won't see pom.xml. So let's say if you have Gradle selected, and if you say Explore, you will see a build.gradle file. Okay, and the dependencies added in the Gradle format. So we are using Maven, so we need Maven dependencies. So I've copied this, and I'll switch over to Intellij. Now in Intellij, just make sure you have your project open. Head over to pom.xml, and I'll collapse this and scroll down. Just go to the dependency tag, okay, and add the two dependencies that we copied into this particular file. Just make sure you copy it under, or you paste it under dependencies tag. Okay, just make sure it is pasted along with other dependencies that exist. So now what happened is we have changed the pom.xml and we have altered the dependencies that exist in our project. Now the moment you edit or make any changes to pom.xml, you're going to see this icon over here. And if you hover on this, it says load Maven changes, which means that you have updated the dependencies or some changes you have done in this particular XML file. So you should reload the changes to apply them. Okay. If you're not seeing this for any reason, you can click on this Maven icon here. Okay. And you can click on this particular refresh icon. So reload all Maven projects. So that will also do the same job. Okay. But since I'm seeing this, I will just click on this and you should see all the dependencies being resolved here at the bottom right. So you're seeing it's resolving all the dependencies and getting all the files that are needed. So you can see everything is being indexed and the red marks have gone. Now we are done with this. Now what we need to do is we need to head over to application.properties file. Now why are we going over here? Because we have just added the dependencies for databases. We need to add and specify some configuration for database. Okay. So we are going to specify the data source URL and we are going to tell Spring Boot that we need the H2 console enabled. Okay. So I'm going to say spring.h2.console.enabled is equal to true. And another property that I'm going to specify is spring.datasource.url is equal to, so this is a URL of our database. I'm going to say jdbc:/h2:mem:/test. Okay, so this is the URL that we are using. So we are using the test database and this is the JDBC URL that we have to specify. We also have other parameters like setting up the username and password, but we are not going to do that right now. Okay, these properties are enough for us to work with right now. And this is just a basic setup. Okay, there are many other properties that you can configure, but we are not going to do that right now. All right, so that's about enabling JPA into your Spring Boot application. Let us start talking about entities in JPA. So what is an entity? So in the context of JPA, an entity represents a table in the relational database. And each instance of an entity corresponds to a single row within that database. So what I mean over here is, you take a look at the job class over here that we have created. Now, entities in JPA are nothing more than POJOs or plain old Java objects. Okay, so here we have this job class. It's a class which consists of some fields. Okay, and we are going to define this as an entity. And this is something that will be used as a template to create a table within the database. So this is the entity that we are mapping to the Spring Boot database, whichever database we are using in the background. So in our case, we are using H2. Now, whenever you create an instance of this particular class, for example, if you create a job object which represents a job, so that will represent a row in that particular table to which this entity is mapped. I hope I am able to make things clear. So if you are not clear yet as to what entity is and how it works, you will shortly be able to understand when you see all of this in action. So we will start defining this particular class as an entity. So how do we tell Spring Boot that, hey, this is the entity class that I want to persist within the database? So answer is simple with the help of annotations. So I need to say @ and I can say entity. So you can see you get an autosuggest, which is from jakarta.persistence package. So I'll select this and you will see the import statement being added over here. And this tells Spring Boot and JPA that this is a class that is supposed to be mapped to a table. and it needs to be treated as an entity. Now, whenever a table is created or whenever an entity is mapped to a table, the table name is same name as that of the class. So if you want to customize this, like if you don't want to have a table with the name job, what you can do is you can make use of one more annotation. You can say table over here, and here in the bracket you specify name, and the name can be anything like the name that you want. So I can say job underscore table. So what will happen is the class name is job, but instead of having the default name job within the database, you are telling JPA that I need a table with this particular name in the database. So with this annotation, that is being taken care of. Now, every entity that you create needs to have a primary key in the database, and that primary key will serve as a unique identifier for each record in the table. So for example, if we have a table representing jobs, we will have a ID field in the database, which will represent every unique job post or every unique job that exists in our application. So how do you specify that? The answer is with one more annotation, you can say ID like so. So just make sure I is capital. If you specify small, you're not going to get the auto suggest. So you need to say I in caps, and you need to select the one from jakarta.persistence like here. So you can see it being imported. So these are all annotations that are coming in from this package jakarta.persistence. Now this tells like this is the ID or the primary key. Okay. And now you don't want to manage primary key. So far we have been managing primary key in the service layer. So not in this class, but in the implementation. Okay. So here we are managing the ID and we are making sure that it gets incremented. So it starts with 1 and it gets incremented. So we are manually managing this. So we don't need to manage all of this with the help of JPA. Instead, you need to add one more annotation if you want JPA to manage it. Okay. So what you need to do is you can say generated value. So this is the annotation. Okay. And you can specify how you want the value to be generated. Okay. So you can say strategy is equal to generation type dot. So you have all of these various like fields that you can add. So I'll say identity. Okay. So this way it will be automatically managed by the JPA and you don't need to generate values for IDs. Okay. So while saving, even if you don't specify the ID value, it is automatically created. Okay. So that's the beauty. So what I'm going to do is I'm going to comment this table annotation for now. Okay. I am fine having a table with the same name as that of the class or the entity that I have. Okay. And one more thing that you need to keep in mind is we have a constructor that constructs this job object. Okay. But whenever you are working with JPA or whenever you are defining the entities, you need to have a default constructor. Okay. So I'll go over here. I'll say generate constructor and I'll say select none. So this will generate the default constructor without any parameters for me. Now, why is this needed? So this is because entities are objects that represent the persistent data in the relational database. Okay. And this is one of the requirements for JPA entities to have a default no argument constructor. This is needed because JPA needs to create instances of entity class during the retrieval of data from the database, and JPA uses reflections to create instances of entities. Okay, and it populates the properties with the retrieved data from the database. And without this default constructor, JPA won't be able to instantiate any entity object. So that is why this is needed by JPA. Okay. And it is important to note like this default constructor is needed, but along with this default constructor, you are free to have more constructors like this one that are needed for your own purpose. Okay. So they won't hinder in this particular job that JPA is doing. So that's about entities and how it works in Spring Boot. let us start talking about the repository, and let's start defining a repository for our project. So what is a repository? In Spring Data JPA, a repository is an interface that allows us to perform various operations involving a database like create, read, update, and deleting records without writing the boilerplate code. And let us see how we can define such a repository. Okay. So here in the job package, I'm going to say new, and I'm going to have an interface over here. So I don't see an option for interface right now. So I'll say Java class. Okay, so the option is over here. I'll say job repository. And I'll close this. Okay, so we have this interface created, which is a public interface, and it's called job repository. Now, what I'm going to do is I'm going to extend. So I'm going to extend JPA repository. So this is the interface that we are going to extend here. Okay. Now you can create a repository using two repository interfaces. So one is the JPA repository, which we have just used. Okay. And you can even use CRUD repository. So this is another interface that exists. Okay. And you can see they both exist so this one exists in the JPA package, and this one exists in the data.repository package. Okay. Now CRUD repository provides CRUD functions like save, find one, find all, count, delete, and so on. It is useful when it comes to usage of some generic CRUD operations, which means we get basic CRUD operations with the help of this interface into our application. But you can make use of JPA repository. So JPA repository extends the functionality of CRUD repository, and it adds JPA specific methods like you have flush, save and flush, and so on. So if I say over here JPA repository, and if I press Control on Windows, or you can press Command on a Mac, and if you hover on this, it will convert into a link. And you can go over here, you can see you have different methods like save and flush. So it gives much more functionality, okay, as compared to the CRUD repository. So we'll make use of this one here. Okay. Now we need to make use of this repository with the job entity. So we need to tell that over here or specify that. So I can say job. Okay. And we need to specify the data type of the primary key. So the data type of the primary key is long. Okay. And I'll remove this import statement here. So I'm going to optimize imports. Okay. So job repository interface is what we call a Spring Data JPA repository. And it's an interface in a sense that it's not a concrete class that we can instantiate with the new keyword. Instead, the Spring Data JPA will create an implementation of this interface for us to use. Okay. And you can see over here, we have also defined the two parameters that it needs. Okay. Which is the entity type and the type of the primary key that we have. And one of the greatest things of using a repository like this is we don't have to write any implementation code for the repository. So we have to just define like this and we are done. So Spring Data JPA will automatically generate the implementation at the runtime, and we can use it in our application. Like we can use it in our service class over here to like interact with the database, and we will see that how we can make use of it. Okay. So this is about the repository class and the data layer as to how you can work with it. So let us start working to make our jobs persistent. Okay. So what we are going to do is we are going to make use of this repository interface that we have created. And with the help of JPA repository, we are going to make the job entity persist into the table. So let us head over to the service class here. Okay. And not this one. So I need to head over to the service implementation here. Okay. Now, if you take a look at the implementation here, we are managing everything with the help of an array list. Okay. So the data in our application is in array list. So I will be first commenting this part. Okay. The moment you comment, you see red marks all over, which is fine. We have just disabled the array list based data store for the application. So we are going to get this red marks, but we are going to work to replace these red marks with the JPA methods. Okay. So first thing here, what I'm going to do is I'm going to define a repository object. So I'm going to say job repository like so, and I'm going to say job repository here, and I'm going to create a constructor here. Okay. So I'll right click and I'll say generate, and I'll generate a constructor, and this will be for job repository. Okay. So the reason why we are doing this is job repository is a bean that is being managed by Spring, and because of this constructor, it will be auto wired at the runtime. Okay. So you don't need to create and manage this object, and you don't need to create an instance and assign it and initialize it over here. It will all be done by Spring, provided you have a constructor defined. Now what we need to do is here in the find all method, we need to say jobs repository dot find all. And the moment you do this, you see the error goes away over here. Okay. You need to scroll down and you need to modify the create job method as well. So here, instead of jobs dot add job, I'm going to remove this, and I can say job repository dot save job. Okay. I can say save, and I'll pass the job over here. You can see the auto suggest here coming in, like you have to pass the job object. So I'll pass this over here, and I'll add a semicolon. Okay. Now we are done with create job. Now here we need to modify this particular method here. So to get job by ID, what we were doing is we were traversing the array list and we were comparing the ID with every object. Okay. And we were returning the object whenever there was a match. So we don't need to do this. Okay. So what we can do is I can say over here, okay, job repository dot find by ID. So here you can see all the methods that we are getting with the job repository. So the moment you say dot, you can see, you can save, you can find all, you can find all, like find all has different implementations. You have equals, you can, let me say find. So you also have find by ID. So we are going to get this. Okay. And here I'm going to say ID. I'm going to pass the ID, and I'm going to say dot or else. So since find by ID returns an optional, okay, if you hover on this, it returns an optional. You can see java.util.optional. So I can say or else over here. So optional means you can use or else method, which says if the object is not found, you can return a null like so. Okay. And then you can add the return statement over here. Okay. So you can see like a lot of code was reduced, and this way you can get the job by ID. So if the job is found with the help of ID in the database, we return the job, or else we are simply like returning null over here with the help of this. Okay. So this is about getting job by ID. Now you can even delete the job. So here we were again finding the job first, and then we were removing it from the array list. So we don't need to do this. I'll just delete this. Okay. Now here we just need to say return, or we don't need to even return. So we can say job repository dot delete. So we delete by ID, and I'll say ID over here. Okay. And if this is done, I'll return true. Okay. And what I will do is I need to handle like what happens if this particular job is not found. So I need to add a try catch block over here. So if this job is not found, there will be an exception that is thrown. Okay. So I can add a try catch block, and I can say over here catch, and I'll add exception E. Okay. And if there is an exception, I return false like so. Okay. So if the job is found, you delete the job, return true. Else, if there is an exception, you return false. Okay. So you can see like delete method that was provided to us by JPA. Okay. You can even update the job and the code can even become simpler. So here you were using this particular for loop to traverse. Okay. So what I will do instead is I'll use optional over here. So optional job, and I'll say job optional like so. And I'll say job repository dot find by ID, and I'll pass the ID over here. So once we have the job over here, instead of for loop, I'll just remove the for loop. We don't need for loop now. Okay. I'm just going to delete this. Okay. And here I'm going to say if. So I'm going to say job optional. So if job optional dot is present. So job optional or the optional class has this method which is present, which means that the object is present. Okay. So if the object is present, it goes into this if statement, and I'll say job over here is equal to job optional dot get the object. Okay. So we are getting the job object now from the optional object over here, like object of the optional type. Okay. And then we are setting all the parameters over here like we did early on. Okay. And if this is done, it returns true, else it returns false. So you can see with the help of JPA, we were able to make a lot of changes in the service class, and we have actually made use of JPA to persist the data to the database. Also, I would request you all to spend some time exploring this object. So if you press dot over here, you can see different objects that exist. So you can see save over here. So this is to save the job object or any entity for which you have created the repository into the database. So imagine the life without this entire mechanism. You know what we would have done if this mechanism was not present, like this JPA was not present. So in the absence of this mechanism, we would have written SQL queries over here. Okay, so imagine writing like select star from job and handling all the syntax errors as well. So here life becomes so much easy with the presence of all these kind of methods over here. So you can see like all these methods that we get with the JPA repository. And what we have done is we have not done anything. We have just created a repository which extends this particular interface over here. And we have just said repository, please manage this job entity, and the primary key is of long type. And we have everything that we need. Okay. So this is how you can get your job to persist. So I hope you all found this valuable, and I hope you're enjoying learning JPA. Let us start testing our changes that we have done. So what we are going to do is we are going to test that everything works with the database perfectly as it was working earlier when we didn't have the database. Okay. So what I'm going to do is I'm going to first run our application. Okay. And we will monitor the logs over here. So I'll just expand this over here. Okay. Now, if you scroll up over here, okay, you will see this message somewhere. Okay. You can see there is a H2 console that has been made available at this particular URL. Okay. And if you scroll up further, so you can see there is a lot of configuration that is happening. Okay. So bootstrapping Spring Data JPA repositories in default mode. Okay. So it's adding all the dependencies and configuring JPA for you. Okay. And we have specified the database URL. So this is the database URL that we had specified, jdbc:/h2 mem test. And you can see this over here in the application.properties. This is what we have specified. And what it did is it created a connection with the user SA. So it has also given you the username onto the console. Okay. So we'll be using this user over here. And if you scroll down, you can see the console was available for this particular database. Okay. So you can even find this information by pressing Control F over here and typing in H2. So if you type in H2, you will see like there are 9 occurrences, and you can just go down, press next occurrence, and you will see all the information about H2 and whatever is being printed onto the console with the letter H2. Okay. So what we are going to do is we are going to copy this URL. Okay. And I'm going to head over to my browser, and I'm going to go to browser over here, and I'm going to say localhost :8080 /h2 console. Okay, so this is a URL that we got, and if you go to this URL, you will see a page like this open up. Okay, so you can see driver class, JDBC URL, username, and the password. Okay, so here is where you will specify the JDBC URL. So what I'm going to do is I'm going to copy this JDBC URL that we specified in application.properties, and I'll paste it over here. Username is SA, so it's mentioned SA over here. So if you scroll up, you can see user is equal to SA. Okay, so this is a default user. So SA is typed in and there is no password. And I'll click on test connection, and you can see the connection has been successful. Now what I'm going to do is I'm going to say connect. Now when you say connect, you're going to see a table has been already been created. Okay. Now what happened is when you executed the application, the queries to create this particular table were executed. And if you wish to see those queries, you need to add a property over here in the application.properties, which will enable those logs as to what is happening behind the scenes. You can say Spring JPA dot generate and -ddl is equal to true. Okay, and you can rerun this application. Okay, we didn't see the queries being printed because the tables were already created. So what we can do is we can ask JPA to recreate the table. Okay, and for that I can say spring.jpa.hibernate.ddl-auto, and I'm going to say create-drop. So we can tell the Spring Boot application to print whatever queries that are being generated with on the application startup when our database is initialized. So what we can do is I can tell that with the help of application.properties. So we need to add a couple of properties which will indicate and tell Spring Boot that, hey, please print all the SQL queries. So one of them is spring.jpa.show, and I'll say true over here. I'll specify one more property. I'll say spring.jpa.hibernate, and I'll say .ddl-auto, and I'll specify the value as create-drop. Okay, so this first property indicates that SQL statements generated by Hibernate should be logged into the console over here. Okay, and setting it to true enables the logging of SQL statement, which can be helpful for debugging and understanding the executed queries. So since we are in learning mode, we are learning, so we can take a look at what all queries are being generated. And this property configures the behavior of Hibernate's schema generation tool. So behind the scenes, Spring Boot uses Hibernate, okay, to map or create tables. So what we are specifying over here is we are telling to create and drop the tables. So this means that Hibernate will create the database schema when the application starts, and it will drop the schema, like everything, it will delete everything once the application shuts down. So our database will restart and like it will recreate on every application start. Okay, and this is useful for development and testing environment. Okay, you can even disable this later on, but I have added this because we just created the tables. Okay, so we will recreate it. So I'll rerun this and I'll expand this a bit. Okay, So we are not seeing the queries being printed onto the console, and the reason for that is there is a typo in this property. So it is show-SQL, okay, and not just show. Now if I rerun this after making the change, okay, and if you scroll up over here, you will see some logs for Hibernate, and you can see this is the create table query that is being triggered, okay, and this is the drop table query because we have specified create a drop as the property, okay. So you can see all the Hibernate related logs over here, okay. So these were the only logs. Now if you have more tables that were to persist in using JPA, then you would have seen many more queries over there, okay. So this is how Hibernate and JPA work in the background, okay. So our database is working fine. Now since we have restarted the app, we will refresh this and we will test the connection and connect again, okay, because the connection is reset. Now what we need to do is we need to test if everything, like all the APIs, are working fine, okay. So what I will do is I will create a job first, okay. So let us send a post request and it will create this particular job, and I'll send this. You can see job added successfully. We'll switch over to the table, and in the H2 console we'll click on this, okay. So the moment you click on the job entity, you will see this query coming in over here, and there's a select clause. Now I can run this and you will see the data being reflected over here, okay. Now you can add one more job if you want to. So I can say job with ID 2, okay, and I'll send this again. It's added, and if you run this query again, you will see the one with ID 2. Now over here you will see that ID is being auto generated. So we passed an ID of 1, okay, but this was not taken into consideration. All right, let us try the get request. So can you get all the jobs? Yes, you can, and it's working perfectly fine. Can you get a particular job? Yes, you can, and it's working perfectly fine as well. Now let us try deleting a job. So let's say I delete a job with ID 1. Okay, so job has been deleted successfully. And if you go to the browser and if you say run, you see you have job only with ID 2. Okay, you can add a job again. So I'll add a job again with ID, or I'll just remove this with ID part. So it's added, and you will see the ID now is 3. So this is being auto generated and auto maintained. Okay. And now I can even update the jobs. Okay. So I can say updated. Okay. And I'm updating the job with ID. Let's try with ID 1. Okay. You will see 404 not found because the job with ID 1 is deleted. Okay. So I'll update the one with ID 2. Okay. And I'll update this to 2 and I'll run this. So you will see 200 okay. And now if you do a select, you will see, okay, so for some reason, I don't see the update here. So ideally this should have been reflected. So let me go to the console and let me run the select clause. Okay, so it's not being reflected and there has to be a reason for this. So let us head over to our source code and let us see our service class. So here in the job service, while updating, so what we are doing over here is we are updating the job entity, but we are not saving it. Okay, so we need to save as well, right? We need to save the changes. So I'll say job repository dot save and I'll say job. Okay, and I'll add a semicolon and let us rerun the application. Now, if you rerun the application and if you head over here, if you try to get the jobs, you will see the schema is now reset. So we will have to create a job. Okay, we created this job. I'll create one more job. So 2 jobs exist now. And I'll try to update the one with ID 2. And I'll send an update clause. You see 200 okay. Let us head over to the browser and run this query. Oh, so the connection was reset. So I'll connect again and I'll connect to this. I'll select this table and you can see now it's being reflected. So what happened is we used this same method. So the save method was used for updating job as well and also for creating a new job, right? So what happened here is we are making use of the same save method. So based on the ID, the job repository understands whether it should update or whether it should create a new object. So if the object does not exist with the specified ID, it will create a new one for you. Okay. Also, I noticed that we are still incrementing this. So we don't need to, and I'll just delete this next ID over here. Okay. Now the code looks much more cleaner, and now I'll rerun and I'll head over here and I'll connect this again. Connect. Okay. And here from Postman, I'll start creating new jobs. So this is job 1, job 2, and you can get the jobs. Okay. So the other job was, so let me add one more. So 2 jobs are created. Now, if I get the job, I'm not getting all the jobs. So what is happening now is whenever you are sending or triggering an request, you're passing the ID as well. So what is happening is it's only saving the job with ID 1. So if you update this to 1, 2, and if you send, and if you try to get, you will get the same job object, which is the reason. So this ID is the reason why this is being overridden. So I'll just remove this ID and I'll send the query. And now you will see a new job being created. Okay. So you can keep on sending as many jobs and it will create for you. Okay. And you can update the job as well. So I can I'll remove the ID field from here as well. Okay. And I'll update the one with ID 2. Okay. And we'll try getting the job with ID 2. Okay. Okay, so there is no job with ID 2. Okay, I believe we got an error over here. So we will update the job with ID 4. Okay, and it's 200. Okay, so I'll try getting the job with ID 4 over here, and it works perfectly fine. Okay, so all the APIs are now working fine. Okay, so you can test it at your end. Okay, and you can save all the requests if you wish to. So I'll just save everything. Okay. So this is how you can make use of JPA to get your data to persist.